So right now we will talk about how to run some terrain analysis in GRASS GIS 8.2. Usually, right from inception, I think all the GRASS GIS so far have had two panes. You can see this pane can be moved around, and of course, so can the map pane. So this is more like the layer pane where you control operations within the map window, which is this one. So we've actually imported some data from the 8.2 from 7.8 initially, but then right now we're going to work with 8.2 and repeat the same process. Now, the setting of the map window, those settings that I performed to enable the importation of the raster data that I generated still have to be implemented in 8.2. The only difference is that it opened it automatically, opened the map window automatically in 8.2, but I still have to perform those settings before I'll be able to kind of run any analysis in 8.2. So to do that, move your cursor over these tools above the layer window. When you come here, it said create new location in current GRASS database. That's what we did for 7.8 before we're allowed to get into the map interface. So you still need to do it here in order to analyze whatever you want to analyze. So that's the bottom line. This one is download a sample location from a GRASS database. Nope, not looking to download. So I want to create a new location. Click on that. And now this gives you the same pop-up window that we had, or something similar to the pop-up window that we had for uh, the previous version of GRASS GIS. Now, new location, let me still call it Anambra BB. Now, let's change it to something else, BB operations. Anambra BB operations. Description. Uh, Terrain analysis for Anambra states using uh, using GEM. So having described that, of course, like I said, this is my very first time of using GraphJS 8.2, so I might run into hitches here and there. But of course, in the end, we'll successfully generate the output because it's not really so very different um, from the GraphJS 7.8 that I'm used to. Click next. Now it says the same pop-up window where you had to select to define the coordinate system or coordinate reference system using a georeference data file. That window still pops up here. So let's see whether we can find the one we're looking for. Select CRS from a list of lists by EPSG or description. Nope. Read CRS from a georeference data file. That's what we're looking for. Create a generic Cartesian coordinates system that's x, y. Additional methods: specify CRS using WKT string. Specify CRS using proj4 string. Define custom CRS. Mind you, CRS is basically coordinate reference system. So the easiest option is to go direct to what you want to do, which is basically read the CRS from your georeference data file. Click next as usual. Browse to find that data file. The data file is Anambra BB Select that, open. Click next. The same thing that was generated for The 7.8 is still basically what is generated here right now. Finish. The same prompt about wanting to whether I want to import the data or not. I still select yes. I can choose to select no. It doesn't really matter that much. And then say, well, whatever they read off here, I said data file, so and so and so. That's the source of the data. And of course, outputs, well, imported successfully. The locations, the location's default region was set by this imported map. Okay, that's what I want to do. Bang. Current location is this. Current map set is permanent. Okay. And now you see the reload. The first definition just went boom, disappeared, and then it appeared with the new settings as which is in line with what I just presented to it. So it is basically how to open your Grass GIS, and of course how to define your work parameters. If you don't define these work parameters, then you will not really be able to do anything in a Grass GIS. Now, having defined this, you'll be saying, where is the map? I thought I told it to open the map. Well, it did open the map. If you come here, you see Anambra BB operations underscore. You see permanent, which is of course which this is basically the name permanent for the other definition, which I didn't change, and then this is the map itself, Anambra BB dem. To make it appear in the window, simply double click on it. Double click. You can still open and right click and say display layer. I haven't tried that before, but I think it will work. But if I double click on it, it will still open. But let's try this display layer, which I haven't tried before. Display layer, and boom, it appears. Don't mind the fact that it now looks very different from what it looked like in my QGIS. But it's still the same thing. It's just a different set of configuration. Grass GIS has a way of using this blue things to display the data elevation model when it should be a black white thing. Now let's see what this area looks like in QGIS. Not this. This selects. And that's the same area, the same map window. Let's shift it to the side and watch them side by side. Now you can see it's still about the same configuration. Watch this corner here. You still see the same corner. This definition here is still this definition here. You see this, which is this. See this region, still this region. Is just a color configuration thing, but it's still the same set of data. The value of each of those each of these pixels is exactly the same as the next, but it's just the symbology that changes. So let's go back to GrassGIS. Now to analyze this and generate your slope map, this is a raster. So you go to raster here in the menu bar, click on raster, go down terrain analysis. When you get to terrain analysis, you see a context menu showing up beside it. You go down and you would definitely find slope and aspect. r.slope.aspect. Click on that. It loads this pop-up menu where you now define what you want to run. Of course, it tells you, it's already telling you the title of the pop-up pane is r.slope.aspect. It will enable you to generate the slope and the aspect of the site for which you have a DEM. But of course, my main interest in this tutorial is the slope. So we said, 1, name the input elevation raster that you have, the digital elevation model. You click on this arrow at the end of this space and select Anambra BB dem. It is selected. You can't run it right now because there are other things you have to define. This is under required. You've defined the inputs. Go to outputs. What kind of output do you want to generate? Click on this tab here. It opens up a new set of uh, definitions to be made. Said name the output slope raster map. This time around, you don't need to click and select. Even if you click, you'll see this thing, but you can't really define that. You need to type in a name that suits what you're trying to create. I want to create an Anambra DB slope. Now, do I want to create an aspect? You can, it still enables you to define the aspect, which is the direction the slope is facing. I don't want to define that. The profile curvature, you can also define it here. The tangential curvature, no. You can define the partial deviation, first order partial deviation. So basically there are a couple of outputs you can generate automatically at a go, just like that. So you can generate all of these at a go. So once you give it a name, it will compute it and load it into your layer, your data layer. But I just need slope for now, so I'll just provide a name for slope and leave the others blank. So it will give me only computation for slope. Whereas anyway, if I go down and type in a name for aspect, for instance, it will give me slope and aspect. But let's focus on slope at the moment. If you want to generate other things on your own when you're working, even beyond this course, then you know that you can do that using this tool. So settings, you click on settings. I don't think you need to change anything here. So if this is optional now, you can decide to change the default definitions, but in this case, you don't have to. So leave it the way it is. You can, you have, but of course, we might still decide to make some amendments. Let's say, for instance, I want to kind of, I'll still generate a map, a slope map, a slope degree map, and slope percent. So the format here, this is in degrees now. The first one I'll generate, once you click and select percent, it will generate slope in percent. But let's generate a slope in degrees. That's where you get it from. Under settings, you can now set what you want to generate. F cell, you have different, you have cell, F cell, and D cell. Let's leave that the default, which is F cell. Multiplicative factor, you don't want to make it by, let's leave it as 1, the multiplicative factor. You don't want to kind of overstrain the the format. Let's just make it 1:1. That's what basically it's all about. So you are not really trying to disfigure the slope that you're trying to compute. Now, having done that, you can go to optional where you select a lot of that other things, but you don't need to leave all of that as it is. You have the command. This is when you run this, the automatically to bring it to command output where it takes you through the steps as it generates the outputs. On the manual, you see something like a rough outline that tells you what the tool does and how to operate it, what it requires as input, the kind of output it generates. This is more like a tutorial on how to use and the value of the tool that you're using. So haven't defined the inputs and of course the outputs and of course the settings at degrees. Just click on run. Run is running under that command now. You can see that it just automatically went to command outputs and now it's telling us that it's finished. And if you check on the panel, on the pane here, you see Anambra BB slope. Now let's go back again and repeat it for percent. Go to required, it's still the same thing that you have there, no change. Outputs, the same thing, but let's add percent, slope percent. So settings, change from degree to percent and run. And the map shows up. So we have generated the slope map for uh, uh, our study area, which is basically the region around Anambra State in Nigeria. So press close to close the pop-up window. Close. Now you cannot see the slope. To be able to see what is below, you can right click on this first layer and say show metadata display layer. So right click and say display layer for the slope, and then the slope BD slope shows up. If you right click on slope percent and say display layer, it shows up too. So you see it's somewhat different, but it's still the same pattern for both slope percent and slope itself, but the units actually is basically what differs. But since it's a different map, then you still get to see that it has different settings in terms of different settings in terms of the symbology, the coloring. I think I'll pause this for now, and then we'll continue with the analysis to generate a new classes or slope classes based on this.